let's have a quick look at SQL, and the query is only that is only learning how to read data from a database. We are not interested in writing data to the database, which is a little bit more complicated. And we will use Python, obviously, and the way you do it almost everywhere is to, in Python at least, is to write a string with your SQL query, and then supply it to the, you can see in this case here, you supply here's a string, and then you supply it to a method, in this case raw SQL, which is the one that Words have implemented in their package. You should know that what we are doing here is what's called the PostgreSQL dialect. All Oracle or Microsoft, they all have tiny small differences from each other. It's not a big deal, but if you change from one database provider to another, and you might want to check, if you stumble across things that seems weird, you might want to check Bing Chat or something. There's no code highlighting in Python. There is, but it's not working very well. So a better option is, if you're really interested in code highlighting, is to go to a dedicated SQL application and then write your code in there, and then you can get your highlighting, and then you can copy it back to Python if you want. But the syntax is quite simple, actually. So let's see if we can manage without code highlighting or anything. You write select, and then the column names you want, what kind of data you want, and then you write from, and then the table name, that is the table from which you want the data. So normally the database is fixed when you do these queries here. So you're only pointing to the table. And as you can see, we are not singling out any rows. So basically, you're asking for all the observations for these column names. And as you can see, I've written here limit 10, and that's because the global factor table have 24 million rows, and that's not exactly what we are after here. So we will just ask for the first 10 of them, and we don't have a connection, so we'll quickly import the words database and form a connection. It takes some time because it's also loading pandas, I think. So there we are, and then we run the select, and then this star is selecting all of the columns in the table. And because it's PostgreSQL, we have to write the name of the database in front of the table. So we only have we also have so we have the database and we have the table name. And then we have the limit 10, so we only get 10 rows, and these are the ones we can get. So to get a little bit less output, we can run you can have, it's interesting, but it's not something you do very often, but you can have SQL can do a lot of calculations for you, but that's when you are in Python, you don't want SQL to do calculations for you. You want Python to do the calculations, but some of them are pretty useful. So let's run this one here, which is the same as before, but here we are counting the rows in this table. So we don't need the limit to 10 to limit the output. So here we only get, let's see, it takes some time to count the 24 million rows. At least the first time, I think there's some cache implemented, so the next time we ask for it, it will be a little bit quicker. But it takes some time. It actually took so long, so I paused the video. As you can see, 1 minute and 37 seconds. I think the Americans are awake now, so the server might be more busy than in the morning. You can see there. Here's the count of the rows. So there are many, and if we, as I said in the previous videos, we also have a global factor in another database called Contrib Global Factor, a more exclusive database, and then we have the same code here. We're counting the rows. So let's see if it also takes a long time, or I have to pause the video in. No, now it's only taking 1.3 seconds. But you can see it's the same number of rows, so that indicates that it's probably the same content. We don't have any code highlighting, but SQL don't care much about casing and line breaks and spaces. As you can see here, I've written what we had in the first statement here, just in another way. Most interesting is perhaps that the string is now this kind of string, 3 citation marks here, which also allows us in Python to have to span more than one line at a time. But as you can see, I've just written it. I spelled everything correctly, but besides that, it's pretty chaotic, everything here. So you don't have to take very much care about these kind of things in SQL. One of the nice things about SQL is that you can single out the columns you want, which I've done here. So select, and as I told you before, you can write the name of the columns you want. I've done that for 3 of them here, and then you can, this is as before, from the database table, and then we have the limit 10, so we don't drown in data. So yeah, there's no output here, and that's because I've signed it. I have assigned it the output to the output variable, and if we go to the Jupyter here, you can see here the variables, and we can see the connection, and now we also have an output variable. We can already see it's the size of it. It's 3 because we have 3 columns or variables, and we have 10. Limit 10, we have 10 observations, but it's a data frame also, so we can ask for a data viewer here, and then we can see, I don't know why this is taking so long. Here it is. Here the ID, the end of month, and the country, as you can see. So so that's one way of getting less data. But we still have 24 million rows if we don't have the limit 10. The way one way to limit the number of rows, which is not obviously a goal in itself, but it's quite handy that you don't have all data up in one query, is to ask for the same columns, and the way you do it instead of this limit 10 is that it's much more common to have the where statement here. So you have a where, and then you write something you want to apply for each row you get back. So in this case here, you only get back, this is the variable that holds the country. So in this case here, we only want results back for Denmark, this is a code for Denmark. And I write here that we should note the citation marks for strings. And that's correct because we have the outer string citation marks here, and then we have also citation marks for Denmark, and that's because this is a string in itself, so we have to indicate that we're dealing with a string and that this variable here have string values. If it was a number, instead we didn't need these citation marks here, but we will see that later on. Let's just try to run the code and see how long time it takes to get all the Danish returns, or Danish, columns, or not columns, rows. So it seems like it was pretty quick to run through 24 million rows to check which of them are Danish. In reality, it usually takes less time, but I think the server is busy now, as I said before. But if you look in the output here, you can see this is it's still a data frame we get out, but you can see there's almost 70,000 observations. So there's still a lot of data, and compared to the speed here. So, but yeah, that's one way to get less return or less output. But obviously you have special needs, and then you will write those here, and we will come back to that later on. So here's another example of where clauses. It's, let me see, it's a perm number of, this is the one for Apple, I remember, and so what we are asking for here is the first two lines here are the same as before, and then we are asking for the perm number of Apple, and note that that's a keyword here, and then we write a new condition, and it don't have to be equality here, but here we have a condition on the date, so the date has to be less than 2001, 1st of January. That's a format. Yeah, it's a little bit tricky format, but that's the way it is. You can see not only strings have these citation marks here around dates. And you could perhaps also note the format here, but it's actually not the same format as is used in the SQL output, but that's, this works. But we have more than one condition, and we have that the end of the month should also be higher or equal to the 1st of January in 2000, year 2000. So we run it again and see what happens. And we can if we want, we can check out the output here for Apple. There's nothing fancy about that, except that the end of month variable has another format, it seems, and I think we should take a closer look, because not only is the output not only have the date, but also the timestamp here, but it is enough to write like this. Or obviously, if you want conditions on the timestamp, you have to be a little bit more elaborate on your queries. So that's basically it before we're ready to replicate the replication crisis paper. So let's stop here.